Are the variables that have levels or some categories within them. Okay, so in the audience, can any one of you give me an example for a categorical variable based on the description that I have given here? Can you give me a simple example for a categorical variable?
Socioeconomic status.
Yes, exactly. Socioeconomic status. So you have, let's say, very simple, I would say poor or middle class or upper class, something like that, right? So it has levels within a variable. Now, as I mentioned earlier in the flow chart, qualitative variables can be further classified as nominal variables and ordinal variables. So nominal variables are the ones that are categorical, but the levels within this variable do not have any order. The order is basically absent, right? So to give you an example, gender is one of the most simple example for nominal variable. Let's say gender, you have male, female, and transgender, right? So these are three levels of the variable gender. There is no order. You can't say males are superior to females or females are superior to transgender. There is no meaning for the order uh, in the different levels of variable gender. Similarly, we have pin code, which are meant for identification purpose, basically for the postcodal level. And then we have name of individuals, again, are meant for just identification purpose. At the same way, the religion. So these are the examples for nominal variables. Now coming to ordinal variables, these are the variables that have order present. So the levels within this variable have some hierarchy or some ordering. So can someone give me an example for an ordinal variable? A categorical variable that has level, that has order in the levels.
Stages of cancer.
Yes, stages of cancer. Yeah, and one more example.
Body mass index.
Body mass index, yes, very good. So I think I have the similar examples here. Severity of disease or stages of cancer. Let's say whether it's in the initial stage or stage 2 or stage 3 or so on and so forth. We have education level, maybe school education, pre-university, university and higher studies, and then BMI categories, body mass index categories. Very good. So these are all the examples of categorical variables, but these are specifically ordinal in nature. Coming to quantitative variables, these are the variables that have counts or measurements done mainly in the numerical scale. So these are some quantity, as the name itself says, you have some numeric associated with the variable. So under quantitative variables, as I have shown earlier, we have two types, discrete variables and continuous variables. Discrete variables are the variables that can take distinct values. To give you an example, number of accidents in a day. So the number of accidents in a day can either be 5 or 6. It cannot be 5.5 or 5.75. That has no meaning, right? So if I say 5.75 accidents, it doesn't make any sense. So these are the variables that take count or they take distinct values. And then we have variables that are continuous in nature. These are the variables that can take any value in a given interval. Can someone give me an example for a continuous variable, a quantitative variable that can take any value in a given interval?
HB
Sorry?
level.
Height.
HB level.
Weight.
Okay, a lot of examples. HB level, yes. Height, weight, any other? Can you think of any other example? That can take any value in a given interval.
Temperature.
Temperature, yes. Okay. I think that's about enough examples we have. So height and weight, these are the simple examples that I can think of. So I'm assuming that now if there are someone who's seeing this for the first time, the types of variables, I hope that you have learned something about the different types. So let me test you now. I have some examples here and I would like you to identify, first of all, whether it is a quantitative or a qualitative variable, and then be specific about what type, whether it's nominal or ordinal or discrete or continuous. Okay. So the first example is number of textbooks owned by a student. What do you think? What kind of variable is it?
Discrete.
Discrete variable.
Yes, discrete variable. It's a count, right? So you can count the number of textbooks a student owns. So it's a discrete variable. Marks scored by college graduates.
Continuous variable.
It's a continuous variable because it's marks, so you can be as specific as you want. Gender of employees of a
Nominal.
company. It's a
Nominal.
nominal variable. Yes. Hospital ID of patients.
Nominal.
Is there anyone who
Ordinal data. Ordinal.
request mute? It's let me correct you all. It's a nominal variable because just like how I explained before, we have pin code or name. So these are all meant for identification purpose, right? So if a person has hospital ID 1 and
Yeah.
another person is hospital ID 2, person with ID 1 is not superior to a person with ID 2, right? There's no meaning. So it's meant only for identification purpose. Such variables we call as nominal variables. Okay, just like pin code or name. So I hope now it's clear to all of you the different types of variables. Okay, and we will see all of these later when we have a hands-on session in SPSS. And again, I'll emphasize there as well on the different types. Now, after types of variables, let's quickly move to the concept of descriptive statistics. Under this, we will see the following: measures of central tendency, partition values, measures of variation, frequency, and percentage. So, first of all, before we start understanding these concepts, why is it that you need to learn about descriptive statistics? What is the importance of descriptive statistics? Now, let me give you a scenario. Imagine you have done a survey as a part of your research study, and you have collected, using a questionnaire, you have asked information from the study participants regarding their age, their gender, their economic status, their marital status, their HP level, or whatever information they can give you. And at the end, if you look at the Excel data sheet that you would have a huge amount of numbers that as it is does not make any sense. If someone is asking you to report your findings, if you just dump these information to them, it's not going to make any sense. So it's very crucial that the first stage of any research is to describe the data. Okay, how do you describe the data? Using the descriptive statistics or summary statistics. Okay, so the first thing that we will look at is the measures of central tendency, one way of summarizing or describing the data. So under central tendency, let's see different types. But what is exactly central tendency? It's the property of concentration of observations around a central value, which means there is one number that can be used to summarize or represent the entire set of observations for a given variable. So rather than giving, say, individual responses, you can use one number to summarize responses of all the participants. That's the power of central tendency. So there are different measures under central tendency, but the most commonly used ones are mean, median, and mode. That's what we will see now. And later I'll also explain to you how, if you have a variable, how to get the values of mean or median or mode using SPSS. Okay, so you can use that as a summary for the data that you have collected based on your research. So what is mean? I'm sure you all are aware of this arithmetic mean. How do you calculate it? If you have, let's say, height, I have collected a value of height in centimeters for 10 people. If I ask you to calculate mean, arithmetic mean, can you tell me how you will calculate?
Sum of all
Part of
observations
it
by
was
total number of
by
observations.
and divided by the
Yes, all of you are correct. You just have to add up all these observations, all these values, 168, 175, add all of these and divide by 10. That will give you the average value of height or mean value of height. Okay, so if I have to mathematically show, this is the formula. Well, of course, if you have, imagine if you have like 500 such people, 500 people have responded and they have mentioned their height. Of course, you can't sit and manually calculate that. That's the reason why we have these softwares that will help us in, within seconds, it will give you the value of mean. But it is always important that you understand what is actually the theory behind all these calculations, right? So that's the reason why I'm giving you all this small introduction. Now, although mean is very, very useful in summarizing any variable, it has a little bit of issues. It has a drawback in few situations. For example, in a situation like this, imagine a basketball coach wants to know what is the average height of his team, right? Now here, if you see, majority of the students have height almost similar, but there is one fellow who is very tall compared to the rest. Now, the problem is when you compute mean in such scenario, the average height will be extremely, shifted towards the height of this fellow, and it will misrepresent the height of the majority of the children. So that's one of the issues with mean. So it is highly affected by extreme values. Just because of one extreme value, the mean can be shifted completely on one side. So the issue here is that what I'm trying to emphasize is that mean cannot be used as a summary in every situation. So in situations where you have extreme values, or in statistical term, we call this as skewed data. Whenever your data is skewed, that's when you report the summary measure median. Okay, median is also a measure of central tendency, but it is most suitable on data which is skewed. As the one example that I showed earlier, there will be some extreme observations in your data. In such case, instead of mean, it's ideal to report median. Now, how do you know whether the given observation is skewed or whether it is extreme? That's a question that will be answered in the next session, where Dr. Kalesh will explain to you about the concept of normal distribution. You'll be clear about the concept of skewed or extreme data in that session. But for now, please understand that whenever your data has skewed observations or extreme observations, it's always ideal to report median rather than mean. Okay, please make a note somewhere. Now, what is median? Median is the middlemost value of the observations when the observations are arranged in order of magnitude. It's very straightforward. All you have to do is arrange your set of observations in either ascending or descending order and find out which value falls exactly in the middle. Okay, so what median does in that case is, since it falls exactly in the middle, 50% of the observations will lie below the value of median, and the rest 50% of the observations will lie above the value of median. Okay, let's see one simple example here. So imagine I have a data like this. You can see that the first 4 observations are very small compared to the 5th observation, 197. So if I have to calculate median here, what's the first thing I have to do? Directly find out which is the middlemost value. Is 5 the middlemost value here?
Arrange the data and make the ascending or descending.
Yes, exactly. So the first thing, you should not forget this. Of course, you don't have to manually calculate anything since you have software, but the concept works like this. So you have to, first of all, arrange them either in ascending or descending order. So here I have sorted them. Now, can you tell me which is the middlemost value? Which is the median?
3.
Median is 3. So I hope it is clear to all of you. So what happens here is, even though there is an extreme value 197, you can see that the median is not affected by it. It is representing the majority. That is the beauty of median. But if you suppose report mean in this case, you can see that mean will be quite high, around 40 or 50, which will completely misrepresent the majority of the observations. Okay, so that's about median. Now let's move to mode. So what is mode? It is the most frequently occurring value in a set of values. Whichever value is repeated multiple number of times, that value itself is the mode. So if I have this example, this data with me, can you tell me which value is the mode here?
15.
15. Why would you say 15?
It is the most repeated one.
Yes. So if you see, out of these observations, 15 has occurred thrice, 1, 2, and 3. So since it has occurred most frequently, the value of mode is 15. What about here?
15 and
19.
Is it 19 or 15?
both missing. Both 19.
Very good. It is both. Okay, so you should know here that unlike median and mean, where you had just top one value for mean or one value for median, mode can be more than one. Okay, so it is simple. Whichever number is occurring maximum number of times, that becomes your mode. So here 15 and 19 both have occurred thrice. So both of them are mode. Okay, so that is about the measures of central tendency. Next, let's move to partition values. Okay, so this is another way of summarizing the data. And as the name itself says, partition. So basically what these do is they will partition your set of observations into multiple parts. Okay, so the first measure of partition values is quartiles. So what quartiles does is it divides the distribution of data into 4 parts. Okay, so if you have, say, a set of observations, something like this, you will have 3 points, that is Q1, Q2, Q3, which will divide the entire set of observations to 4 equal parts. So first part comprises of 25% of the observations, second part 25, third part 25, fourth part 25, altogether 100%. So you need 3 points to divide your entire set of observations to 4 equal parts. Now, what are these 3 parts? Q1, we call this as the first quartile. Okay, this one. Q2 is the second quartile and Q3 is the third quartile. Now, if you focus here on Q2, you can see that it is exactly in the middle and there are 25 plus 25, that is 50% of the observations below it and 50% of the observations above it. What do you think this Q2 is? We have seen something similar to this earlier.
Median.
It is nothing but, correct, it is nothing but the median. Q2 or the second quartile is essentially nothing but the median. Okay, now let me give you a quick example because you know that it divides the data to 4 parts, but what is actually the interpretation? Suppose if you calculate, let's say a first quartile for a variable, say height, what is the meaning of it? So let's see the interpretation. Okay, so imagine that for a variable height, these are all the values of height measured in centimeter, and using the formula, there is a formula to calculate first quartile, second quartile and third quartile. I'm not going to discuss the formula here because we have a software with us, but we will see how to interpret these values. Okay, now for the variable height, when I calculated the first quartile value, it came to be 151. The second quartile value or the median was 157 and the third quartile value was 163. What is the meaning of these 3 points? Let's see that. So Q1, the first quartile value was 151 centimeters. So where does it fall? It falls here. So what does it mean? You can see that below this value, there are 25% of the observations. Above this value, there are 25 plus 25 plus 25, total of 75% of the observations. This is essentially the meaning of the first quartile value. So what is the meaning of it? 25% of the students have height less than the value of 150, sorry, it should be 151 centimeter. And the rest of the 75% of the students have height more than or equal to 151 centimeters. Is that clear? If 151 falls here, that means 25% of the students have height less than 151 and the remaining 75% of the students have height greater than 151. That's the meaning of Q1. Now, can someone tell me what is the interpretation of Q2, 157 centimeters? What percentage of students fall below the height of 157 centimeters?
60%.
50%, yes. So 25 and 25. So how do you interpret 157?
25% of the students have the height less than 156 centimeters and the rest have 157 and more than 157.
Yes, exactly. So as you know, median falls exactly in the middle, right? So in other words, it means that there are 50% of the students who have height less than this value, and the remaining 50% of the students have height greater than or equal to 157 centimeters. Now someone can tell me 163 Q3, what's the meaning of this? What percentage of students fall below the height of 163? 75%. And what percentage of them have height greater than 163? 25%. Yes, very simple and straightforward, right? So 163, you can say 75% of the students have height less than 163 centimeters. Sorry, again, it should be 163 and 163 here. Rest of the 25% have height more than or equal to 163 centimeters. So this is how three values, that is Q1, Q2, Q3, will give you an idea about the entire variable height. Okay. Now, similar to quartiles, you have seen that 3 points, Q1, Q2, Q3, divided the entire set of observations to 4 equal parts. In the same way, we have something called as deciles and percentiles. So what deciles do? 9 points, D1, D2 up to D9, these 9 points will divide the entire set of observations to 10 equal parts. The same way you can interpret deciles, the way how you interpreted the quartiles. And we also have percentile. So 99 such points will divide the entire set of observations to 100 parts. Now there is a relationship between the quartiles and the percentiles. It is like this. The 25th percentile is nothing but the first quartile value. The 50th percentile is nothing but the second quartile value, which is the median. And the 75th percentile is nothing but the third quartile value. Okay, so this is the relationship between percentile and quartile. Okay, so that was about partition values. Now let's quickly go through measures of variation. So what are these? Basically, these will tell you the dispersion or the variation that is present in the given variable. Okay, the first measure is interquartile range. So you have already seen what quartiles are. This is a way of representing those quartiles in the form of a range. That's what is interquartile range. Okay, so let me tell you first what is interquartile range. As you can see here, it is nothing but the first quartile value and the third quartile value. That's it. So what you have to do for any variable that has extreme values or which has skewed data, I already mentioned that for such variable, instead of mean, we report median as a measure of central tendency, right? Whenever your data is extreme, it has extreme values or it has skewed data. Now, along with median, you can also report the interquartile range. Okay, to just give the audience an idea of what is the variation present in that particular variable. So this is one way of reporting the variation that is present in the data. The other way of reporting the variation present in the data is through variance. Okay, so basically what variance tells is on an average how far each of the observations, x1, x2, x3, x4, imagine these are all values of height. Okay, x1 is 120 centimeter, x2 is 130 centimeter, and so on. And for all of these, you can calculate a mean height, right? Which we denote here as x bar. So what variance tells is, on an average, how far each of these individual observations are away from the mean. So if the variance is very small, it means that all of these observations have value somewhere close to the mean. If they are very far, I mean, if the value is very large, it means that the observations might deviate very far from the mean. That's the whole idea of variance. Again, there's a formula to calculate it, but you don't have to worry about the formula because we have a software with us. So I will explain to you how to get the variance for any given variable. Another measure of variation is standard deviation, which is nothing but square root of variance. So if you just calculate the variance for any variable, let's say the value of variance for height was 25 centimeters. To get standard deviation, you just have to take the square root of that value. So square root of 25 is 5. So standard deviation of height will be 5 centimeters. So that's how the variance and standard deviation are related. Okay. Now, as I mentioned earlier, when you have a variable that is skewed in nature, you report median and interquartile range, right? Now, in case if your variable doesn't have any extreme values or doesn't have any skewness, in that case, you can report mean as a central tendency. Along with that, you can report standard deviation as a measure of variation. Okay, so it's always like this. Median and IQ are together and mean and standard deviation will be reported together. Okay. Now, to understand whether the data is skewed or not, as I said before, you'll have to wait for the next session where it will be clear to you. But at this point, you should understand that mean and standard deviation go together, median and interquartile range go together. Okay. So that was all about summary statistic or descriptive statistic for quantitative variables, whatever we have seen so far. What about qualitative or categorical variables? How do we summarize them? Okay, so imagine that you have done a survey study where you have asked the study participants whether they smoke or whether they consume alcohol, and based on their response you have entered as yes or no. Okay, so if you see person 1 says yes for smoking but no for alcohol, so like this we have entry. Now if you have to summarize these two variables, how will you summarize? Do you report mean and standard deviation here, or median and interquartile range?
Frequency.
Mode now.
Frequency.
Yes. So yes. So it should be frequency, right? Frequency. What is frequency? Basically, it's a count. So you should be able to tell. If imagine there are 500 people who have answered whether they smoke or not. Out of these 500 people, how many of them said yes? And out of these 500 people, how many of them said no? That is nothing but the frequency or count. And along with frequency and count, you can also report the percentage. Okay, so here this is how you summarize smoking and alcohol variable. So basically you say out of the total number of people, 53.3% of them said they consume alcohol and 40% of them said they do not smoke. So it sort of gives you an idea of the entire variable just with the frequency and percentage. Now there is another way of summarizing the variables, something called as 2 by 2 table or cross tabulation, where at the same time you can summarize two variables. So if you see I have taken alcohol variable in the column and smoking variable in the row, so simultaneously I can tell how many of them said yes for both smoking and alcohol. Can you tell me what percentage of people or participants said yes for both?
50%.
50%, right? You can see this
50%.
particular. Yes, exactly. So these are the people you can see because it's corresponding to yes for alcohol and yes for smoking. So 50% of them said yes for both. What percentage of them do not consume alcohol but smoke? What percentage of them do not consume alcohol but they smoke? What is the answer?
71.4.
Yes, very good. 71.4, because you can see it corresponds to no for alcohol but yes for smoking. So this is how just with 4 of these cells with frequency and percentage, you will be able to summarize the two variables at the same time. We call this cross tabulation. So we will see this as well after this theory session on how to get these cross tabulation or 2 by 2 table in SPSS. Okay. So just to summarize whatever I mentioned in the past 15-20 minutes, whenever you have categorical variable or qualitative variable, the appropriate way to summarize them is through frequency and percentage. And if you have quantitative variables, the first thing you need to know is whether the data is skewed or not. Like I said, whether the data is normally distributed or not. So at this point, you don't know how to check that, but you should make a note of this. Whenever your data follows normal distribution, you have to summarize it using mean and standard deviation. SD is standard deviation. And if the data is not normally distributed, you have to report the median and interquartile range. Okay, so this is how we summarize our variables. Okay, now let's move to the software part. So I'm assuming that all of you have installed the software SPSS. I think most of you might have the demo version. So if you have the software installed, can you please double click on the software icon and keep the window open? If you are new to the software, I'll explain to you how to import the data set to SPSS. So while I'm talking now, parallelly, you can work on keeping the window of SPSS open in your respective systems. Okay. So just to give you an idea, well, there are many options available on how to perform statistical analysis, especially the packages. Okay, so of course in this particular workshop we are focusing on the SPSS software, which is a paid software. You can only access the demo version of this, a trial version of this software for free, but if you need the original licensed one, you need to pay. Similarly, we have other software packages such as Stata, Minitab, MATLAB, SAS. All of these are paid softwares. But there are software such as R and also Python that are free. And there is this particular package of R, which is called as EasyR, which is, I would say, almost similar to SPSS, because even in EasyR, you have easy options on menu driven where you can click and you can get the answer. And this is totally free of cost. Okay. So just to give you an idea that there are multiple options available if you want to analyze your data. And if you want to calculate sample size for your research study, there are software such as NMaster, which is software developed by CMC Vellore. And there is another software called My Sample Size, in short MSS, which is developed by the BCC team, using which you can calculate the sample size for your research studies. Okay, so these are some of the software packages available. So with that, I finished the theory part, and I am now quickly going to the software part, that is the hands-on session. So hope all of you have, those who have the software have opened the window and are ready. Those who do not have access to the software yet, if you had issues with installations and all that, you can parallelly note the PDF that we have sent to you, which the first session will be on this particular PDF, that is data manipulation and descriptive statistics using SPSS software, where we have given you a step-by-step screenshot of all the data manipulation and summary statistics that we are going to do now in this session. So in case if you don't have the software, you can keep a look on this and you can make your notes accordingly. And when you have access to the software, you can follow it. Okay. So please don't think that if you don't have software, you won't be able to do anything today. You can still make your notes. Fine. So all of you are ready? Now, for those who are new to the software, I'm going to explain to you how you can import your Excel data set. Okay. All of you, I hope, are having access to this software. This particular Excel data sheet, which is cross-sectional. So we are going to work on this particular data set throughout the workshop, and I will explain to you how you can import this particular Excel sheet to SPSS. Okay, so to do this, go to option file, open data. So if you click on this, you will be directed, you have to actually tell the software where exactly you have saved your data. I have saved mine in desktop. So if I go here, and if I click on files of type here, it only shows SPSS data sets for now. So you can click on this drop down button and select Excel. So if you do this, it will display all the Excel sheets that are available in the destination. So since I'm going to work on cross-sectional data, I'm going to select it and click open. Okay, and if this Excel sheet has multiple sheets within it, you have to specify which sheet. Okay, for now it has only sheet 1, so I'm clicking OK. I'm not going to make any changes, and if you see now, you will observe that the variables that were in Excel have now come to SPSS. Okay, now there are certain things that in terms of the data entry that I would like to give you some tips. So in case if you're planning on entering the data of your maybe the responses of a questionnaire or anything, I would always suggest you do it on Excel rather than on SPSS directly. It's always easier to enter the data in Excel and then import the data to SPSS. Okay, so there are certain things, certain rules that you have to follow so that you can make the data accessible in SPSS software. There are certain etiquettes that you have to follow. The first thing is, whenever you have categorical variables in your questionnaire, for instance, you have asked people about their gender or marital status or religion, these are all categorical variables. Always enter the responses in the form of number. So you always have to give a code to each response of your categorical variable. Say, in this case, 1 represents male, 2 represents female. Okay, instead of entering male, MALE, or M, or any such character, it's always better you convert them to a code and enter the numeric. Okay, and you can do the same for all the categorical variables. And whenever you're entering values of a continuous variable, for example, age, you should avoid mentioning 34 years or 38 months. Okay, these kind of entries should be avoided. So you should strictly keep it as numeric, and you have to make sure that all of these entries are of same unit. That means all of these values are in years. Okay, so never mix up numeric with string, because the software will not allow you to analyze them further. And if you have something like a variable where there are 2 words, do not use space like this, because SPSS will not allow you to have a space mentioned in the variable name. You can either use underscore, sorry, or you can use a dot or a full stop to separate the two words. And in case if in your questionnaire some of the people have not responded to what religion they belong to or what their age is, rather than saying NA or no or not available, you have to leave it as blank. Okay, so whenever you have a blank in SPSS, it understands that it is missing. You don't have to specify it is missing or not available. Okay, so overall what I'm trying to convey is that when you're done with your data entry, your data Excel sheet should have only numbers. There shouldn't be any letters, any characters. Okay, no years, no months, no yes, no male, female. As much as possible, try to code your variables and enter the code and not characters. If you have done this, then your data is perfectly clean and you can directly load it to SPSS for further analysis. Okay, so now here if you see, this data set is completely clean, doesn't have any characters, any mixed up words and letters or numbers in any entry. So this supposedly is a clean data. Is that clear to all of you? I hope you have understood how to import the data and what are some of the basic etiquettes of data entry. Okay, now the first thing that we will do is we will understand what type of variables we have with us. So as I told in the beginning of the class, it's always important you should know the difference between quantitative variables and qualitative variables. Now, can you tell me what kind of variable is age?
Quantitative continuous variable.
It's a quantitative variable. What about gender?
Qualitative variable.
It's a qualitative. What about income?
Yeah. Income is a quantitative variable.
Quantitative variable, right? So this is all of course, many might have already done some research work, some data analysis, but for students, you should please know the difference between what are qualitative and what are quantitative. Because if you don't know the difference between them, you wouldn't know whether to report frequency and percentage or whether to report mean and median. So you should not report mean and median for a variable such as gender, right? Because you know that it is a categorical variable. Okay, so please understand, if you have your data, suppose if you have done a survey study, the first thing you have to make a note on is how many categorical variables I have, how many continuous variables or quantitative variables I have in my data. Okay, so the first thing now we will do before we move to any data analysis is I will show you with an example how to label these variables. For example, I told you that instead of writing male, female every time for every participant, you have to use a code. Let's say 1 for male and 2 for female. That's what we have done here. But if a third person, suppose who's not part of your study, is seeing this, he may not be aware of what is 1 and what is 2, right? So you should be able to make this data more meaningful. So even another person who's not part of your study will be able to understand. So the first thing we will do is we will label these categories of a variable. Is that clear? So what we will do to do it is, if you see in the bottom, there are two windows. One where you are viewing now, which is called as the data view, and the other one is called as the variable view. So you have to go to this option, variable view, and you can see all the variables listed here. Okay, this is the data view where you can see the values for each variable, and in the variable view you can see all of these variable names. So now I want to specify one in gender means male and two means female. To do this, you have to go to this option called values. Okay, all of you, just see what I'm doing. I'll give you some time to work on your own as well. So here in values, you have to click on this tab which has three dots, and here you have to specify value 1 means male and value 2 means female. Add. Okay, don't forget to add, and then click OK. So now if you see, it is saved. So 1 means male, 2 means female. You can go back to the data view, and now if it is not visible, there is this option. You can see where my cursor is, which says 1 and A. Click on that. If you click on that, you will see instead of 1 and 2, now it displays as male and female. Okay, now as a practice, quickly, can you also do a relabel for the variable tobacco chewing? Here you have entry 0 and 1. 0 means no, the person doesn't chew tobacco, and 1 means the person chews tobacco. So the same way, can you go to the variable view now and label that variable? So click here. 0 means no and 1 means yes. And click OK. Is that clear to all of you? Is that clear to all of you?
Yes, ma'am.
Okay, fine.
Yes,
So
ma'am.
now, okay, fine, great. So you have labeled the variables now. So the same way, if you have time, you can do it for all the categorical variables that you have in the data. Okay, so it will make your data more meaningful. So now, after labeling the variables, the first thing that now that we will do is we will summarize our variables. So as I mentioned earlier, you have mean, median, mode, all of these for quantitative variables, and you have frequency and percentage for categorical variables, right? Now, if I want to summarize age, which measure of summary should I use?
Mean and standard.
Mean and standard deviation. That's what ma'am is saying. I think that is correct. You can use mean and standard deviation to summarize age, right? So let's see how to do it. You have to go to this option, analyze, and under that there is an option called descriptive statistics. Under that we have an option called frequencies. Okay, descriptive statistics, frequencies. Click on this option and you can select the variable of interest, whichever you want to summarize. So here it is age. So I'm selecting age here. Okay, and please remember this one particular thing. Whenever you're using the option frequencies to summarize any quantitative variable, here age is a quantitative variable, right? Whenever you're using frequencies option to summarize a quantitative variable, remember to uncheck. You don't need this option, display frequency tables. You have to uncheck it. Okay, and it will tell you have turned it off and say that's fine. Okay. Please remember this. Whenever you're using the option frequencies for a quantitative variable, uncheck this option. Once you have done that, if you see there's an option called statistics, click on the option statistics, and here you will see all the options that I have discussed earlier. You have mean, median, mode, you have standard deviation, you have the minimum and maximum of the variable age, you have variance, you have quartiles. Whatever summary measure you want to report, you can click on that and just continue. Okay, or you can just, for to understand, you can just click on everything for now. Okay, don't worry about whether you have to report mean or median. For time being, you can just see the summary for all the statistics for the variable age. So from this table, you will come to know that the mean of age is 42, then 42.72, standard deviation is 10.8, and you know that variance is nothing but square of standard deviation, so that is 116. Minimum value of age is 30, maximum value of age is 69. The first percentile or first quartile value is 34, second quartile or median is 39, which is the same thing, and 75th percentile is 49. So anything that you want to summarize for variable age, you will get everything in just one option. Okay, so this is how you summarize age, which is a quantitative variable. Now, as an example, can you please tell me what is the mean of variable weight? So here we have a variable which is called weight, I think somewhere in the end. Yeah. Can you tell me what is the mean of weight and standard deviation of weight? You have to quickly do this, whatever I showed you earlier, and tell me what is the mean and standard deviation for variable weight. I'll give you half minute for this.
Ma'am, is it 57.60 mean?
Okay. Let me check that. $57.60. Yes, exactly correct. And the standard deviation is
10.53.
10.53. Yes. So as you have seen, what I did is I did not just do anything, I added. So if you want to summarize all of these variables, you can send all of them at once and just click OK, and you will get summary for all the variables in one click. Okay, so this is how you summarize the variables, but make sure you're unchecking this option because all of these are continuous or quantitative variables. So we don't need that option. Okay, so if you are done with all these and if you want to do something fresh, you have an option called reset. So you can just click on the reset tab and everything will be back to how it was before. Okay, I just clicked on reset. Is that clear to all of you? Now we have summarized variables such as age, height, weight, fat intake. All of these are quantitative variables. Now, how to summarize variables such as gender? Can you tell me how to summarize gender?
Frequencies.
Frequency and percentage, right? Count and percentage. So how do we do that? How to summarize this? Again, you can go to the same option as before. Okay, analyze descriptive statistics frequencies. Now this time, select the variable of interest, but do not uncheck this option. This option, display frequency tables, is specifically meant for categorical variables. Earlier we used quantitative variables, right? We were summarizing quantitative variables. That's why I unchecked. But this time, we don't have to uncheck it. That's it. You select the variable, categorical variable. Don't make anything. You don't have to select anything. Just click OK. If you do that, you will get the count. So you can see that there are a total of 914 males and the corresponding percentage is 50.4. Now, because I labeled, in the beginning we labeled that 1 is male and 2 is female, right? That's the reason why in the output, you are able to see male and female. If you have not labeled them, it will display as 1 and 2. Okay, so if you want the report to be more meaningful, it's always advised that you label your variables first. Now, can you tell me what percentage of the study participants are tobacco chewers? We have a variable tobacco chewing, right? What percentage of them said yes for tobacco chewing? Can you answer this question for me? What percentage of the study participants said yes for tobacco chewing?
14.2.
Okay, let me cross check that. Someone said 14.2. Yes, that is correct. So you can see here, there are a total of 14.2% of people who said yes for tobacco chewing. Okay, so This is how you summarize any categorical variable. Now, if you remember in my slide, I had also showed you something called as cross tabulation, where we had summarized alcohol consumption and tobacco or smoking simultaneously, right? With the cross tabulation. Let's see how to do that in SPSS. Okay, now suppose I want to summarize and find out what percentage of males said yes for tobacco chewing. So you can see that I'm connecting the two variables, gender and tobacco chewing here. I'm not individually asking what percentage of males are in the data set or what percentage of tobacco chewers are in the study. I'm saying, I'm asking what percentage of males said yes for tobacco chewing. So to be able to answer this question, I need a cross tabulation. So I'll explain to you how to get that. To do a cross tab, you have to go to the option, analyze, descriptive statistics. Now this time you have to select the option cross tabs. Okay, select the option cross tabs or cross tabulation, and here you have to select one variable in the column and one variable in the row. So now what I will do is I will select gender in the column and I will select tobacco chewing in rows. Okay, after selecting the two variables, to get the percentage, let's say I want to know among males, which is in the column, what percentage of them said yes for tobacco chewing. To know this, you have to go to the option, the third option here, cells. Click on cells, and here you have an option which gives you counts. Of course, we need the frequency. Along with that, we also need the percentage, right? So we will click on this percentage, column percentage. Okay, you click on column percentage in the option cells, click continue and click OK. Now you will get a 2 by 2 table like this. So if you see, I have variable gender in the column and I have the status of tobacco chewing in the row. And my question was, what percentage of males said yes for tobacco chewing? What is your answer based on this table?
16.2.
Yes, very good. 16.2% of people, right? Because you can see a total of 914 males are in the study. And out of this 914, 148 people said yes for tobacco chewing, which corresponds to 16.2%. I hope this is clear to all of you. So
But
because
I
I
have
see,
let me
sorry?
ask now. Suppose you are putting gender in the row,
Yeah.
what will happen? Is there any problem?
There is no problem. It depends on how you want to summarize. Okay. Now let's see. I'll show you. If I don't make any change in the percentage, I am just changing the order. So you are saying if I put gender in the row and tobacco chewing in the column, right? What happens? You can see that the percentage is generated. I selected column percentage, right? When I did this table, if you see, the percentage is total 100 for column for the column, which is tobacco chewing. So what it says is, out of the total number of people who said yes for tobacco chewing, what percentage of males and what percentage of females are there? It depends on how you want to interpret. Accordingly, you have to choose the variable in column or row, or you have to accordingly select the column percentage or row percentage. Because initially my question was, out of the total males in the study, what percentage of them said yes for tobacco chewing? Okay. If I have interchanged the order of gender and tobacco chewing, if I have to answer the same question, I have to select row percentage in this case rather than column percentage. Then it will give me the same answer as before. If you want, I can show you. Here, instead of earlier I selected row, I mean column, this now I'll select row. Remember, earlier the answer was 16.2%, right? Now if you see here, 16.2% is here. So it means there are total of 914 males. Out of them, 16.2% said yes for tobacco chewing. That's the only difference. So it all depends on how you select the percentage, either whether you select column percentage or row percentage. That's it.
Thanks.
I hope that's clear. So what you can do is you can just try it out on one or two variables yourself, and you can try to understand what is the meaning. So you can see where exactly the 100% falls. If you have selected column percentage, 100% will be in the columns. If you have selected row percentage, 100% will be in the row. That's it. That's the only difference.
Thank you.
Yeah, okay. Fine. So now that was about cross tabulation. Now let's try to get summary for continuous variables separately for categories of another variable. What I'm trying to say is, earlier you have calculated the mean and standard deviation and all this summary for age, variable age, right? And this was a summary for all of the study participants, all the 1814 study participants. Now, suppose I want to know what is the mean of age for males and females separately, which this table doesn't give me, right? Because it is giving me mean age for all the 1814 people. But I want it separately for males and females. So how will I do that? So for that, you have to use an option called as split file. Okay, what is that option? It's called split file. So to do it, you have to go to the option data. There's an option called split file. Click on the option split file. And here you have to tell the software based on which variable you want the summary separately. For now, I want the data or summary separately based on variable gender. So what you do, you have to click on this option, organize output by groups, and select the variable gender. Okay, organize output by groups, select the variable gender, and click OK. If you do this, you will get a message which says that now the split file separate by gender. So hereafter, whatever you do will be given separately for male and female. Okay, now can you find out the mean age the same way how we did before? Analyze descriptive statistics, frequencies. We can reset this first. Now select the variable age, because I want to know the mean age and standard deviation of age and all that. And since it is a quantitative variable, remember I told you you have to uncheck this option. So you uncheck it, and then in statistics, select mean, standard deviation, or whatever statistics you need, continue, and click OK. Now if you see, because I split my data based on gender, I'm getting two summary tables, one for male and one for female. So now I can tell the age, average age for males is 42.59, and average age for females is 42.86, and the corresponding standard deviation. So if you see the sample size here, it is 914, that is male, 900 female. The initial summary which we had obtained, that was for 1814 participants, which was all together. Now we have summary separately for male and female. Okay, can you do the same thing now and tell me what is the average weight of people who said yes for tobacco chewing? Mean weight for people who said yes for tobacco chewing. How will you do it?
Excuse me, ma'am.
Yeah.
Could you please explain split file once again?
Yes. Yeah. So I just asked you a question, right? Let me answer that question. So I have a variable tobacco chewing, which is yes or no, and I want to know what is the average weight of the people who said no for tobacco chewing and average weight of people who said yes for tobacco chewing. How will I do it? To do it, you have to first go to the option data, split file. Okay, and here by default it will have the first option checked. You have to check on the third option, organize output by groups, And here you have to select the variable tobacco chewing. Please remember, in split file, you should always use categorical variables. You can't use a continuous variable to split your data. It has to be a categorical variable. And that's it. If you select this variable, just click OK. And now what you're supposed to do, if you want to get the mean and standard deviation of weight, how do you get the summary for a quantitative variable?
So we have to go to the analyze,
Yeah,
descriptive.
the same option, right, which we had done in the beginning. So go to analyze, descriptive statistics, frequencies. Now select the variable weight. Okay, and remember to uncheck this option because it is a quantitative variable, right? And then go to statistics, select whatever you need, mean, median, standard deviation, variance, anything that you need, and continue and click OK. Now, if you see, we are getting the summary of weight separately for those who said no for tobacco chewing and those who said yes for tobacco chewing. Is that clear?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. Now, one thing you should remember is whenever you're using a split file option, once your work is done, you should remember to go back to that option, split file, and reset it. You should always remember to do this because, as I said, whatever analysis you do or whatever data summary or you generate will be separately given for tobacco chewing, which we don't want. Suppose once the work is done with respect to this variable, you have to reset it always and click OK. You should make sure that the split file is off. Okay, so remember to do this. Split file is off now. Now, the last part that I'm going to show you is how to compute and recode. Okay, so let's say you have some variables with you, and based on these variables, you want to create a new variable. For example, I have a variable height. Okay, as you can see, this variable is measured in centimeters. 173.3 centimeter, 146.3 centimeter, all are in centimeters. Suppose I want to get a variable height, but in meters. How will I get height in meters if I have height in centimeters?
Divided by 100.
Divide by 100, yes. So if you divide by 100, the resultant value will be in meters, right? So what you have to do is to create a new variable height, which is in meters, you have to go to this option, transform. Okay, what are we going to do now? Based on the variable height, which we already have, which is measured in centimeters, we want to create a new variable height, but it is in meters. We are creating a new variable. Okay, so to do it, you have to go to the option transform compute variable. Here you have to give a new name because you are creating a new variable, right? So you have to specify a variable name here. Let me say height in meter. You can give any name that you want. Okay, so I'm saying height in meter, and here you have to type the formula to compute the height in meter. So how do you do it? You know that this variable height which you have in the data set is already measured in centimeter. You just have to divide every value of height by 100. That will give you height in meters, right? So I'm using this option, this symbol divide, and dividing it by 100. That's it. So you just have to type the expression here and click OK. That's it. So if you do this, you will not see anything in the output window because you have not done any calculation. Instead, if you go back to your data view, scroll to the end, you will see a new variable created, height underscore meter. So for every value here, 173.3 is now 1.73. Okay. So rather than calculating it individually in a Excel or in a calculator, if you just use this option, for every row, the corresponding calculation will be done. This is how you create a new variable. All of you have done this?
Yes.
Yes, ma'am.
Fine. Now, as a exercise, let's create another variable, BMI, body mass index. Can someone tell me what is the formula of BMI?
18 kg by height in meter square.
Yes, exactly. So we have weight in kg divided by height in meter square. Do we have all the ingredients to calculate BMI in the data set?
Yes.
We have weight here, which is in kg, and we also have height, which we just computed in meters, right? So we have both of these variables, and we can now easily compute the variable BMI, isn't it? So let's do the same thing as we have done before. As we are creating a new variable, go to the option transform, compute variable, and now let's specify a new variable name, that is body mass index or BMI, and let's type in the expression here. So what is the formula? Weight in kg, which is, we don't have to make any changes here because weight already is mentioned in kg in the data set. Divide by height in meter square. So we have created a new variable, height in meter. Just have to square it. So what we will do, we will open a bracket, select height in meter, then use the symbol of multiplication, that is star, and again send the variable height and close the bracket. Is that clear to all of you? What I have done? I have written the variable name, that is BMI, which I'm going to create. Then I'm using the weight in kg in the numerator, and in the denominator, I'm multiplying height in meter twice, height square. That's it. If you do this, your variable BMI will be created for every person. So just click OK. Again, go back to the data view, and here towards the end, because every new variable that you create will be appearing in the end of the data. Okay. So if you see the last column in the data view, you will see corresponding to every person you have the value of BMI. Is that clear to all of you?
Yes, ma'am.
Okay. So you can do this kind of calculation. Suppose you have waist circumference and you want to find out waist by hip ratio or anything that's clinically important to you. You can, based on the existing variables, you can calculate the or compute the new variable. Okay. Now the last part is recoding. So here you have a quantitative variable BMI, but you know that BMI has some standard categories, right? Can you tell me what are those standard categories of BMI? What are the groups of BMI?
Underweight, normal, overweight, obese.
Yes, exactly. So in case if based on the variable you have, you want to identify to which group this person belongs to, whether this person is underweight, whether this person is normal with respect to BMI, overweight or obese. So there is an option called recoding in SPSS where based on a quantitative variables, you can categorize them and create a new variable. Understood what I'm trying to say? You have a BMI variable here. Now you want to find out how many, who are the ones who are underweight, normal, overweight, or obese. You're basically categorizing a quantitative variable. So we will see how to do that. That's the last part, and I'm going to quickly finish that. So to categorize a continuous variable, you again have to go back to the same option, transform, recode into different variables. Okay, transform, recode into different variables. You have to do this different variable because you have two options here, record into same variable, record into different. Always go for the second option. Okay, because if you click the first option, it will overwrite on your existing variable and you will lose the continuous variable that you have. So you have to click on this option, and here you have to specify which variable are you trying to record. So I'm trying to record BMI. Okay. And here again, you're creating a new variable. So you have to specify a name for that variable. So I'm saying BMI category or BMI cat. Okay. Once you have given this name, you have to click on this option change. Once you have clicked on change, go to the option old and new values. Okay, and this is where you have to specify the software between what range to what range of BMI is normal, between what range to what range it is abnormal or obese or overweight or underweight. This is where you have to specify. Okay, so you already know that if the value of BMI is less than or equal to 18, then the person's BMI, you can consider the person as underweight. Okay, let's say it's like that. So here, range lowest through, this will tell you if the person's BMI is less than or equal to 18, then the person here will fall in category 1. Okay, this is the first category. Of course, we can label them as later as 1 means underweight, 2 means normal, 3 means overweight and obese and all that. But here you can't mention normal or anything in string. It will not allow you. You have to give a number or a code. Okay, so if the person's BMI is less than or equal to 18, then the value is 1. So then you have to add. Okay, click on this tab, add. Lowest through 18, 1. What's the next category? If the person's BMI value is greater than 18 and less than or equal to 25, then the person will be normal. BMI is normal. So now we have two values, upper limit and lower limit, right? So we have a range. So now we will use this option, range, and we will say if the person's BMI falls between 18 and equal to or less than 25, then the BMI value will be normal, but category 2. So that again is the second category. And if the value of the BMI is greater than 25, then let's say it is overweight. So it is greater than, again, you have only upper limit. So we will now click on range value through highest, that is 25. And this will be category 3. And add. Once you have selected all of these 3 categories for BMI, once you have defined all of them, click on continue and click OK. Again, if you go back to your data set, you can see now corresponding to the value of BMI, you can see whether the person falls in category 1 or 2 or 3 of BMI. Okay, so if the value is less than 18, greater than 18 and less than or equal to 25, then the person has normal BMI. So that's what it means. Okay, and once you have this BMI category made, as how we have labeled the values of gender and tobacco chewing, even here you can label them. You can say 1 means underweight and 2 means normal and 3 means overweight. Okay, and you can see now instead of 1, 2, 3, it will be normal, overweight or underweight. Is that clear to all of you? So all you have to do is use this option, transform, recode into different variables, specify the variable that you're categorizing, give it a new name, then go to old and new values, then specify using these 3 options, that is range lowest through, range highest and range. Specify the categories, that is the cutoff for BMI and the corresponding value, and just click continue and you will see the variable which is created in the end of your data view. That's it. Okay, this is how you can recode or categorize a quantitative variable and convert it into a categorical variable. In case if it is confusing at this point, you can go back and refer to this, I think, yeah. So we have mentioned that in the handout as well on how you can recode or categorize a continuous variable. You can refer to this and you will understand how it works. Okay, so that was about categorizing a continuous variable. Now, if you want to summarize them graphically, there are some options available in SPSS. If you just go to this option graphs and legacy dialogues, you can see all the options of graph that is present. If you want to say summarize the variable BMI with the bar chart or with the pie chart, you can just select the option accordingly. Select the pie chart option And here, if I suppose want to summarize the BMI categories using a pie chart, I'm defining slice as BMI category. Click OK, and you can see a pie chart is created. So it will tell you what the green slice is for overweight, blue slice is for underweight, and and the pink slice is for normal. Same way, if you want to summarize the variable using bar chart, just specify the particular variable and click OK, and you will see the same in the form of a bar chart. Okay, is that clear to all of you? Anybody has any doubt?
Madam, can you repeat that once more?
Which one? The chart?
Yeah, the last one chart.
Yeah. So you just go to this option, graphs, select the option legacy dialogues, and then click on bar chart or pie chart, any option that you're interested in. And then you don't have to make any changes. Okay, let it be in the default format. Just go to define. And in this option, category axis, select the variable of interest. Now, instead of BMI, let me select gender. Okay, category axis is gender. That's it. Click OK. And in the output window, you will see the graph.
Okay, ma'am.
Okay. Any other doubt? Fine. So again, I'm just trying to emphasize on looking at this handout. So in case if you have any doubt, you can go back later and see how these options work in SPSS. If you have any doubt, you can keep it towards the end. Once the program is done, we can sort it out. Okay. So I think I exceeded a lot of time. So I would like to ask Dr. Kalesh now to start with the next session.
Good evening, everyone. I think my voice is clear to everyone and my screen also visible to everyone. It's fine, no? Hello?
Yes, sir.
Okay. So next some 40 minutes, we will discuss how to perform some few selected hypothesis testing procedure using SPSS software. So before that, I want to ask you a few questions. See here, I listed few variables, SBP, WBC count, and gender. Can you tell what type of variable is SBP? Already a document explained to you. Yeah, very good. It's a continuous quantitative variable, WBC count.
Discrete quantitative.
Yeah, correct. It's a discrete count variable. We are counting how many WBC is there. The last one is gender. Gender is what type of variable?
Nominal, qualitative, nominal.
Yeah, very good. It is a qualitative variable. We can suggest nominal variable or categorical variable. Fine. So if you see the mathematical property of this SBP, that will be entirely different from the mathematical property of WBC count. That will be entirely different from the mathematical property of gender. Why it is like that? Because all these three variables measured in different scale. One in a continuous scale, the other one is a discrete scale, the last one in categorical scale. So based on the nature of variable, on which scale it is measured and the value it contains, there are different type of mathematical properties available. For example, in this case, all these listed variables, gender, MI status, death, exam, all measured in a binary scale. Usually this type of variable has some specific mathematical statistical property, and we used to say, oh, they follows a specific distribution known as binomial distribution because it has a binary outcome variable. The outcome is a binary, yes or no, percent or absent. So almost these variable binary outcome variables have some specific mathematical property. At the same time, if you see this variable, everything measured in a discrete scale, number of WBC, number of platelets, number of accident, number of delivery, everything in a discrete scale, number of. Usually this type of variable, the discrete variable follows some specific mathematical property known as Poisson property, or we used to say there follows Poisson distribution. At the same time, as I listed here, SPP, DBP, cholesterol, height, weight, BMI, hemoglobin level, whatever may be, almost all clinical variable what we measure in a numerical scale, quantitative scale usually follows a specific property, property known as normal property or normal distribution. So what I want to say, based on the nature of the variable, different type of distributions are there. For example, there are more than hundreds of mathematical distributions, probability distributions are available. Among the n number of distributions, the normal distribution is very, very important. Why it is very important? As Dr. Amita already mentioned, when you go for the summary statistics, whether you should summarize something in mean standard deviation or median interquartile range, that is the very basic level of any analysis, the descriptive statistics or summary statistics. There also we are making use of the property of normal distribution. So whenever you have a quantitative variable in hand, you should check the normality. If the data follows normal distribution, then only you can summarize the same in terms of mean standard deviation. Otherwise, you should summarize the same in terms of median and interquartile range. So what I want to convey is very important. For example, you have variable SBP. You can summarize the same in terms of mean and SD, the mean SBP and standard deviation of SBP if your data follows normal distribution. Otherwise, you should summarize the same variable in terms of median and interquartile range. Okay, so as I mentioned, okay, normality is very important. So how we are going to check the normality of the data? So what is meant by this normality? For example, whenever you have a variable, say SBP, DDP, cholesterol, any quantitative variable, just plot a histogram and look at the shape. If this looks like a exactly bell-shaped symmetrical curve, you can say your data follows normal distribution. Most of the participants, today's program participants are nursing MSc students. I hope you all know what are the theoretical properties of normal distribution. So whenever you plot a graph, it should be a bell-shaped one. As I mentioned, should looks like this. And the mean divide the entire graph into two equal halves. And this is a probability curve, so total area under the curve equal to 1. And this side it is a 0.5, this side it is a 0.5. And the tail of the curve comes very close to the horizontal axis, but it will come very close but never touch the horizontal axis. It will extend up to plus and minus infinity. Okay, so that is the one of the property of normal curve. And usually normal curve is the unimodal in nature. It may have only a single mode. So like that, if you see the theoretical property, n number of properties you can list. But the very important property what I want to highlight is skewness. For example, in this graph, you can see the central one is exactly symmetrical bell-shaped one. Correct, no? But this side, you see, this tail is little tapered towards the right side. In this graph, the curve is more shifted towards the left side. If there is a asymmetry, then you can say, oh, that is skewed one. So whenever your graph, when you plot, if it is skewed towards the right side, then you can say it is positively skewed diagram or data. If it is shifted towards the left side, the tail is more shifted to the left side, then it is a negatively skewed data. So skewness actually quantifying the asymmetry, the lack of symmetry. So can you tell in the case of normal distribution, what will be the skewness value? Skewness is lack of symmetry, asymmetry. So normal curve, what is the skewness value?
0.
Yeah, very good. Yeah, the skewness is not there, it is a symmetrical one. That's why it is normal. Very good. So whenever there is a violation from the symmetrical shape, if shape is not exactly symmetrical one, you can say, oh, that data violates the normality assumption. That is one of the main property of normal curve. It should be symmetrical in nature. Then another terminology is kurtosis. See the height of the curve. Usually the black one, this is actually the normal curve. It is written mesokurtic. So usually the curve has some optimum height, say 3 units, then we can say, oh, data follows normality. So that height, in terms of height, if you want to talk something regarding the normal the curve, then it is known as kurtosis. It is actually quantifying the degree to which the graph is bigger. The height of the graph, the optimal height, what we are anticipating is 3 for a normal curve, and the kurtosis is known as mesokurtic. Sometimes the curve will be, see the red one, it's very flat, sometimes very bigger. So whenever it is very flat, say it is less than 3, we used to say it is a platykurtic. If it is greater than 3, it is a leptokurtic. So this is another terminology we should know related to normal distribution. kurtosis. So kurtosis is talking about the height. The previous one, skewness, was talking about the shape, whether it is symmetrical one. This one in terms of it is very peaked or very flat or in optimum height. If it is optimum height, normal. Fine, no? So whenever we talk about the properties of normal distribution, we should say that skewness should be 0 and kurtosis should be equal to 3. It is a mesokurtic in nature. So these are the theoretical property. Almost all students may by heart all these points. Fine. Now, here we are mainly focusing how to check the normality using software. So here, when we go for what manual calculations or not manual calculation, when we go for the hands-on training using software, the software may not list all these points. Some other, based on some other testing procedure, we should say whether the data follows normality. The very simple method, you can just plot a histogram using the SPSS software. And if the SPSS software gives a bell-shaped curve like this, you can say your data follows normal distribution. But by looking the graph, you may think, oh, this curve is not that much symmetrical. It is a little shifted towards the right side, or the height is not that much proper. It is very peaked or very flat. Like that, if you have any confusion, to confirm the normality, we have two testing procedures, the Shapiro test and the KS test, the Kolmogorov-Smirnov test. Okay, why we want two confirmatory tests? Because Shapiro we are using whenever sample size is less, say less than 50. Whenever sample size is greater than 50, you can go for Kolmogorov-Smirnov test. Clear, no? So what I want to highlight, the main one point what I want to convey to you all, whenever you have a data set, you should check the normality of the same. How you are going to check? You can go for this method. Just plot a histogram, look at the shape. If shape is exactly bell shape, you can say your data follows normality. Otherwise, you can go for the confirmatory test known as Shapiro test and Kolmogorov-Smirnov test. Depends on your sample size. If your sample size is more than 50, you can go for Kolmogorov-Smirnov test. And if it is less than 50, you can go for Shapiro test to confirm the normality of the set. So what is the decision rule? Based on what you can say your data follows normality. You just do the Shapiro test or Kolmogorov-Smirnov test, depends on the sample size, and look at the p-value. There will be something known as p-value. If that p-value is greater than 0.05, your data follows normal distribution. So when you use any of the software will display something known as p-value, is a probability value. If that value is greater than 0.05, then you can say your data follows normal distribution. In statistics, whatever assumption you are checking, please note, whatever assumption in statistics you are checking using any of the software, if the value p-value is greater than 0.05, the assumption is not violated. Please note, if p-value is greater than 0.05, whatever assumption you are checking, here we are checking the normality assumption, that assumption is not violated. So the decision rule based on Shapiro and Kolmogorov-Smirnov test is, you should perform using any of the software, look at the p-value. If that value is greater than 0.05, you can say your data follows normal distribution. Okay, now I will show you one. This is actually for the variable height in the data set. Already madam explained, regarding the data set, the cross-sectional data. There we have a variable known as height. I just perform the Kolmogorov-Smirnov test because my sample size was 1814. It is greater than 50. So I performed Kolmogorov-Smirnov test and the software displayed all these things. So here, SPSS software usually instead of p-value, they will write an asymptotic significance. This is actually nothing but the p-value. Okay, and you look at the value here. This is the p-value software reported for the variable height while checking the Kolmogorov-Smirnov test. What is our decision? Whenever p is greater than 0.05, you can say data not violated the assumption. Data follows the normality assumption. So here, can you tell height follows normality or it violates normality?
Follows normality.
Normally.
So others, please, what madam mentioned is correct or not? Others, please.
Normal.
Yeah, someone mentioned it is the following. This variable height follows normal distribution. Fine. So whenever data follows normal distribution, so how we supposed to summarize this variable in terms of mean and SD? Okay, so if you want to summarize the variable height, you should report mean and standard deviation. The software will display everything: mean, standard deviation, minimum, maximum, smallest value, largest value. What is that? The quartile, upper quartile, lower quartile, median value, everything it will display. But it is your duty, based on the normality, you should identify which summary measure you're supposed to use. So while checking the normality, we observed that the height follows normal distribution. So we are going to summarize the variable height in terms of its mean and standard deviation. Here also that is available. Otherwise, you should use the option already madam explained to you. It's clear now up to here. So I used another variable. See here DBP. I check the normality. Can you tell the decision? So this is the p-value. The last row is the p-value in SPSS. Look at the p-value and you tell whether data follows normality.
Not followed.
Students, please.
No.
Okay, very good. See here, this value is less than 0.05. So we can say data not following normal distribution. So for this specific variable, what summary measure we should use? We should summarize in terms of median and
IQR.
yeah, correct. Median and interquartile range Q1 and Q3. I hope you understood when you can say the data follows normal distribution depends on the Kolmogorov-Smirnov test. See here, and one more point I want to say, whenever SPSS displays something like this 0.000, you are not supposed to write P equal to 0.000. This is wrong way of writing. You should report like this: P is less than 0.001. Actually, this is a probability value. You are telling SPSS will display only 3 digits after the decimal point, but after some n number of zeros, there may be some value. So we are telling, okay, that value is a very small value, less than 0.001. Instead of writing it is equal to 0, we are precisely telling P is less than 0.001. That is not that much important in this situation, but whenever you use any hypothesis testing procedure, and if you observe a p-value and if you want to report that p-value, don't write p equal to 0. You should write p is less than 0.001. Understood, no? Now I will show you how to do the normality checking using software. See, already we loaded the data in SPSS, the same data set I have here, age, gender, all the information is here. Now we can just go to, as I mentioned, the variable height. I want to check whether the variable height follows normal distribution. Where is the option? We can go to, please everyone look here what I am doing. Go to analyze, non-parameter testing procedure. See here where I kept my cursor. Analyze, non-parameter test, legacy dialogues, and one sample KS test. Excuse me. Yeah, I hope you understood where is the option. Go to analyze, non-parameter testing procedure, legacy dialogues, and one sample KS test. When you click here, please listen what I am doing now. Later I will give you time to do yourself. Okay. See here, you will get a dialog box like this. So which variable you want to check the normality, height, just drag that to this side. And here by default test distribution is normal. Click OK. So when you click OK, software will produce the output here. And here you can see the same I projected in my PPT. The p-value found to be 0.06. Data follows normality in the case of variable height. Now we are going to check the normality for another variable instead of height. Here only you can select the variable gender, income, and selecting many variable here. DVP also was there in my list. So I just click OK. Now you tell what about the age, whether age is normally distributed. See, this is age. See the value? Yes or no?
No.
No, some are mentioning yes in between. Okay, whenever value is greater than 0.05 only, we can say data follows normality. Here for the variable age, income, and DVP, see the value, it is less than 0.001. So we should say these variables violate the normality assumption. Among the 4 variable what I listed here, height, age, income, and DVP, only height follows normality. So for the variable height, I can use summary statistics, mean, standard deviation. For other 3 variable, I should use what median and interquartile range. Correct, no? Is it clear to everyone how to check the normality?
Yes, sir.
Okay. That yes is not that much strong. Okay, she have again some confusion, I think. Okay, so I have a variable here. You just tell fat intake is normally distributed or not. Just check the normality of the variable fat intake and you tell whether that variable follows normality or not. And if you have any doubt, I may be a little fast, you can just use the handout given in the form of PDF. Everything is step by step. What I use, the same example is there in the handout provided. You can make use of the same also. So whoever has system and already loaded the data, can you check the normality for the variable fat intake? The option I will tell you where it is. Okay, okay. Madam said, okay, the data violates the assumption of normality. I thought, I asked whether can you do, she said no. Okay, very good. Okay, so Madam already mentioned it is violating the assumption of normality because value is less than 0.05. Very good. So whenever you have data with you know all the categorical variable, just estimate the frequency and the percentage. Quantitative variable, if you want to summarize, you should check the normality first. What and all found to be normally distributed only for those variable you report mean standard deviation. Otherwise, you should report median and interquartile range. Normality checking is very, very important. So in the summary statistics onwards, we are making use of the properties of a normal distribution. I hope now you understood how to check the normality of the variable using SPSS software. Is that clear to everyone?
Yes, sir.
Okay. Now I will come to this point again. Why I mentioned about the normality, this normal distribution. I will come back to the same topic later. Now we will go to something known as testing or hypothesis. I am not going to tell in depth what is hypothesis testing or that is statistical type 1 error, type 2 error, power. All those things I am not going to explain because this is the SPSS training program. I will just give you what is meant by hypothesis testing and we will do hands-on training using SPSS. Okay, that will be more effective instead of learning lots of theory. Okay, see, I mentioned we are going to discuss hypothesis testing. So can you tell what is meant by hypothesis? What do you think?
Relationship between the two variables.
Yeah, please note that it is not always a relationship between variables. I think most of the nursing textbook it is written relationship between two variables. For example, I want to know whether the average birth weight of the preterm babies in Kerala is similar to the national average. There, I am not doing any relationship comparison. Here, I just want to compare my average value, the score based on the population with a standard value. So that also hypothesis testing. So instead of using such a definition, you can say hypothesis is actually the statement about the population parameter. So what is that statement? Any statement about the population parameter can be hypothesis. That may or may not be correct. I can say drug A is better than B. I can say Covaxin is not that much effective as Covishield. I can say it may rain today. I can make any statement. So whatever statement I am coining, those all statement is actually known as hypothesis. So in statistical hypothesis testing procedure, what we are going to do, we are going to see, is there any evidence to support the hypothesis what I coined based on some mathematical theory? You understood, no? So we are using some statistical procedure to check, is there any evidence to accept our hypothesis what we coined is known as a testing of hypothesis. So hypothesis actually means any statement about the population parameter that may not be always what relationship between the variable. That also a hypothesis testing, but that definition is not proper. So hypothesis testing, as I mentioned, it is the statement about the population parameter, and in a testing procedure, we are using mathematical theory to say, is there any evidence to support our hypothesis? What we call it. Based on that only we are going to decide whether to accept or reject the statement. Okay, so whenever we write a hypothesis, we will write the research problem in two different forms. I think everyone is well known to these points. One is a null hypothesis, the other one is the alternative hypothesis. So what is null hypothesis? Is actually the hypothesis which is to be tested. Usually it's a negative statement and denoted by H naught. And the alternative hypothesis is just opposite of that one, that is usually denoted by HA or H1. I will explain with one example. For example, your aim is to know is there is a difference in the average SPP between two groups, say males and females. You have two groups, males and females, and you want to know in your research whether the average SPP is same for males and females. So here you can coin your hypothesis like this. The null hypothesis is H0, alternate is H1. Null hypothesis, a negative statement of the same problem. You can say there is no significant statistical significant difference in the average SPP between males and females. The positive way you can state the same, there is a significant difference in the average SPP between males and females. This is the way whenever you have a problem with you, you should list the hypothesis H0, the null hypothesis, H1, and alternate hypothesis. Is that clear? I think everyone is very familiar to these things. Fine, no?
Yes, sir.
Okay. Now we will see based on what you are going to accept or reject this hypothesis. So when you go for students, can you tell what is the manual calculation when you do manually, how you will make the decision whether to accept or reject the hypothesis for any testing procedure in statistics? So whenever you go for t-test or ANOVA or chi-square, whatever may be, the calculated value is greater than table value, you will reject the null hypothesis. Correct, no? This is the way whenever we go for manual calculation, you are doing the decision. But here, when we go for a software, any of the software, all software will give you something known as p-value. It will quantify in terms of probability whatever you observed is due to chance or not. I'm not going in depth of those points, theoretical point. You should know there is something known as p-value. Based on that only, we are going to make the decision. So whenever you do any hypothesis testing procedure, and if your p-value is less than 0.05, you can reject the null hypothesis. That means there is a significant difference. So we are rejecting null hypothesis only when the p-value what you observed is less than 0.05. If it is greater than 0.05, you accept the null hypothesis. I written fail to reject. You can accept the null hypothesis whenever p is greater than 0.05. Is that clear? So whenever the p is less than 0.05, you should reject the null hypothesis. Clear, no? This is the decision rule we are going to use. Is that fine?
Yes, ma'am.
Okay, yeah.
Yes,
This
sir.
is a statistical decision rule we should use for all the hypothesis testing procedure. Okay. When you go for manual calculations, students, MSc students, you should use this one because we are not calculating manually the p-value. It is little complicated. You should calculate the t-statistics or f-statistics or chi-square value, compare with the table value given in the question paper. And when you compare the calculated value is greater than table value, reject the null hypothesis. As it is a training program, usually we will go for based on the p-value. The decision is based on the p-value. We have two decision rules. Okay, so p-value, based on the p-value only, we are going to explain today. Okay. So already I mentioned the hypothesis testing. We know what it is. We will coin the hypothesis as a null hypothesis or alternative hypothesis, and we will decide whether to accept or reject the same in terms of the p-value. Whenever p is less than 0.05, we will reject the null hypothesis. The entire hypothesis testing procedure in statistics is divided into two based on the normality. Suppose your data follows normal distribution, you should go for something known as parametric testing hypothesis. Otherwise, you should go for non-parametric method. You see the influence of normality is very, very important. This is a very significant branch of statistics, the hypothesis testing process. That itself again divided into two, depends on the normality. If your data follows normal distribution, you should go for some specific type of testing procedure that is commonly termed as parametric method. So if you are telling I use a parametric test, that means your data follows normal distribution. If your data violates the normality assumption, you should go for something known as non-parametric test. So how we can check the normality? Plot a histogram and see the shape of the curve. If it is a bell-shaped one, you can say data follows normal distribution. Okay, see here a few parametric and non-parametric tests I listed. Independent sample t-test, ANOVA, paired sample t-test, and repeated measures ANOVA. And here you can see the non-parametric analog. This is actually the analog of the same. For example, if you have 100 parametric testing procedure in statistics, 100 non-parametric version also you can identify. So each and every parametric method you have a non-parametric analog. The same situation you can handle, you can do the hypothesis testing different way, depends on the normality. One is the parametric way, the other one is non-parametric way. You understood, no? So for each and everything, there is a parametric and non-parametric. Nursing students mainly, you maybe learn what is that correlation. Pearson correlation is the Spearman correlation is. So Pearson we are using to see the relationship between two variables. Whenever data follows normality, if data violates the normality assumption, you should go for Spearman's correlation. So large n number of parametric and the same n number of non-parametric methods also there. So we are going to discuss today few parametric testing procedure, independent sample t-test and ANOVA. And these are the other parametric testing procedure, paired sample t-test and repeated measures ANOVA. But here today we will explain you how to perform independent sample t-test and ANOVA using SPSS software. These all listed for test, no? Everything is actually looking for whether the average value, the mean is same in different group or same group at a different time point. Without wasting time on this, I will directly move to what is meant by independent sample t-test. Okay. See here, we have two group A and group B. And if you want to know any of the continuous variables, say SPP, DBP, cholesterol, height, weight, hemoglobin level, whatever you want to compare between these two groups, male or female, cancerous patient or normal patient, whatever maybe. If you want to compare between two groups, any of the continuous variable, and if your data follows normal distribution, see I written if data follows normality, you can go for something known as independent sample t-test. So independent sample t-test is a parametric testing procedure to compare the average value of any of the continuous variable between two independent groups. What is the main assumption? The data should follow normality. So whenever you want to compare any of the quantitative variable which follows normality between two independent groups, males and females, something like that, then you can go for independent sample t-test. Clear, no?
Yes, sir.
Okay. So independent sample t-test, as I mentioned, it is a parametric testing procedure. So what is the main assumption? Data should follow normality. Then only we can use independent sample t-test. What is the meaning of that? When you plot a histogram among the first group, data should follow a bell-shaped curve. Here also data should follow bell-shaped curve. Then only you can go for, then you can say data follows normal distribution. Otherwise, you can use KS test or Shapiro test to confirm the same. Or just to plot the histogram. Okay, I will show you how to do all these things in SPSS. Then we have another assumption for independent sample t-test, equality of variance. That means when you estimate the standard deviation of this group, that should be approximately equal to standard deviation of the second group. So that is known as homogeneity of variance. There is a test known as Lebanese test or Bartlett's test that will confirm the assumption whether it is violating or not. But the main assumption is nothing but normality assumption. Even if you are not checking the second assumption, you should check the first assumption, the normality assumption. So I think students are familiar with this test strategy. Whenever you are doing manual calculation, you should estimate the mean and the standard deviation from two different groups. Use this equation, substitute everything, calculate the t-value, compare the calculated value with the table value, make the decision. That is the way we are doing, no? The manual calculation. We are going to do the same using software now, so don't worry about this point. Okay, this is the manual calculation equation. Okay. So whenever you go for independent sample t-test, you should check the normality first. Suppose I have a research problem like this. Is there a significant difference in the average SPP between two groups, say males and females? How I should write the hypothesis here? Like this. There is no significant difference in the SPP between males and females. There is a significant difference in the average SPP between males and females. Clear, no? Now, first what I should do? Whether I should directly go to the option independent sample t-test or before proceeding, I should check something. Can you tell that? What I should check?
The normality first.
Yeah, I think it is a Sindhu ma'am, correct. Anyone else? Students? Yeah. See here, whenever you have a problem like this, first you should check the normality of the variable SVP separately for these two groups. Among males and females, whether data follows normality. If data follows normality, you can proceed with the independent sample t-test. In this particular situation, in the data set what we have, I checked the normality and I observed that SPP is following normal distribution among males and females. So I proceeded with the independent sample t-test. I will project the output now. And see here, these are the different statistical packages, and we are using this only, the SPSS software. So this is the SPSS output for the research problem. We have two group, males and females, and here we have the software will display like this. So here, this is very important. You should report the mean and the standard deviation for both the group with the n. Whenever you write the n, no, better to use small letter n. Usually capital letter n we are using for the population size. It should be small letter n for sample size. So how many males are there? How many females are there? What is the mean value? What is the corresponding standard deviation? Like this, we should keep the output. So these are very important. This is the actually the SPSS output only. See here, when you go for when you scroll down, you will get something like this. Lebanese test. Lebanese test actually looking for homogeneity of variance. So that is the sig always p-value. So Lebanese test p-value is telling it is a point. What is the Lebanese test value? 0.119 p-value. Whenever the value for any assumption checking, if it is greater than 0.05, assumption is not violated. So equality of variance assumption not violated. If not violated, you should use this row. If assumption is violated, see the second row, equal variance not assumed. If assumption violated, you should use this row. So here the equality of variance assumption is not violated. So you should use, this is the t value and this is the p value. Otherwise, just no need to too much bothered about this Lebanese test. You can select the first one. This is a higher level. If you want to check the second assumption, you can just see the assumption is violated or not based on the p value of a Lebanese test, and you decide which row you should select. Both are independent sample features result only. One is based on the Lebanese test assumption hold or it is violated based on that. So here you can see t value and p value. See here, when I reported like this. Instead of just to copy paste the SPSS result, you supposed to report the result like this whenever you have values. For example, for the result of independent sample features, what are the groups, males, females, how many sample was there. N is equal to 914 in this group. Here it is 900 SBB with the mean and standard deviation. At least 2 digits should be there after decimal point. And it is, this is optional. If you want, you can keep that also. And the p value. See the p value and tell whenever p is less than 0.05, reject the null hypothesis. This is the decision rule. Correct? No? So can you tell, is there any difference or not? What is the null hypothesis? There is no significant difference in the average between males and females that we can accept or reject.
Accept the null hypothesis.
Yeah, here we should, yeah, whenever p is less than 0.05, we will reject. If it is greater than 0.05, our value what we observed is 0.807, so it is greater than 0.05, so we are accepting the hypothesis. Our inference is nothing but there is no statistical significant difference in the average SPP between males and females. So whenever we write a statement, we should support the statement with the p value. You should write within the same sentence inside the bracket p is equal to this much. That's why I use the term statistical significant. Okay. In this specific case, no need to do any testing procedure. You can just look at the mean value. See, this is 150 here also approximately 150. By looking the value itself as a clinician, you can make or oh, there is no difference. Why you should do a t-test? Okay. Mean. Otherwise, also there is no difference. Summary stance itself is telling there is no difference. But if you want to proceed with the t-test, you can do. And the test is telling there is no significant difference in the average SPP between males and females. Now, we will do the same using the software. Please listen here. Go to analyze. Don't worry, within 15 minutes I will conclude everything. Please listen. It may exceed the time 8:30. Around 8:45 we will wind up. Okay. Please try to join with us. See here, go to analyze. First, what we should do, I should check the normality of the variable SBP separately for males and females. Now, if I want something separately for, when I click the, see here, go to analyze, non-parametric. Here, if I click any variable, it will produce the normality checking only for that variable, irrespective of any category. If I want separately for male and female, what I should do?
Click file first.
Yeah, very good. every time the same participant will be giving the answer. Okay, go to data. We should use this option split file. So which variable I should select? Any students?
Gender.
Gender, yeah, very good. Gender, we can select here, click OK. So now software, whatever we are asking software, now software will give separately for male and female, whatever we do. It is splitted for the variable gender. So for male and female, whatever we ask, software will display. For example, if I descriptive cases, if I display here, for example, gender, age, any descriptive cases, click OK. It will produce for males what is the mean, median, mean and standard deviation, minimum, maximum, separately for female also. This already madam explained to you, no? So now we are going to check the normality. Go to norm here. See, go to analyze, normal distribution, legacy dialogues, one sample case test, variable of interest is SBP. Now when I click, software will separately check the normality for males and females. For the variable SPP, separately for males and females. So I click. See here, among males, where the data follows normality, SPP follows normality. What is the inference? Yes or no? See where I kept my cursor, 0.146.
Yes,
Data yeah, data follows normality. Very good. Among females, where the data follows normality?
yes, it does, sir.
Yes. Now we observed that the assumption is not violated. SPP variable is following normal distribution among males and females. So the main assumption of independent sample test is not violated. So we can proceed with independent sample t-test. So whenever we use that option, as madam mentioned, you should reset and click OK. Now we are going to do independent sample t-test. Go to analyze. Here we have option comparison of mean independent sample t-test. The option is here. Go to analyze, comparison of mean independent sample t-test. Here we should select the variable SBP. And what is the grouping variable? Grouping variable? Gender. Yeah, gender. So we can, what code we given? We given 1 and 2, no? 1 for male and 2 for female. We can give that code here. The exactly the same I given in the handout. How to do these things. Click continue, click OK. So when you click OK, software will produce the output. So here this is a descriptive status means standard deviation sample size for male and female will be there. Here down in this box you have independent sample t-test t value. Here this is the t value and this is the t value. If you want to check the Lebanese test, this is the p-value of Lebanese test. Test is telling the assumption is not violated. You can use the first row, and here this is the p-value. This p-value is telling there is no significant difference in the average SPP between males and females. Is that clear to everyone? Once again, I will tell you. Go to analyze, comparison of means, compare means, independent sample t-test. Test variable, we want to check SBP is significantly different between the grouping variable gender means males and females, and define groups. What code we given? If you given 100 and 200 for male and female code, you can type that. Here I given 1 and 2, 1 for male, 2 for female. Then click OK. OK. See here the descriptive statistics, independent sample t-test result. Clear, no? So, but whenever you report, you're supposed to report like this. Okay, fine, no? So now I am not allowed to remove that. Is that fine? Clear, no?
Yes, sir.
Okay, now I have a question for you. See here, I compared the average value of SPP between males and females. Can you tell one situation where you can go for independent sample t-test? You can say, I want to compare the average cholesterol level between normal subject and obese subject to independent group quantitative variable. If it is normally distributed, you can go for independent sample t-test. Something like that. Can you give one situation, one example? Okay, in this specific research question, I may go for independent sample t-test if data follows normality. Two group, any continuous variable. Students, please. Hello. Anyone, please? Even if if there is no students. To answer this, any of the participants can give one situation. Like here, this one situation, male and female, I want to compare the SPP. You can say I want to compare the cholesterol level between two
Alcohol
groups.
and smoking.
That is what is the continuous variable? You want to compare the average value of something. Both are categorical, no there. Any example, please? In situation where you can do independent sample t-test, t-test always comparing the quantitative variable between two groups. See here, I listed no here. See, this is the situation. Any quantitative variable between two groups. Yes, please. Hello. If you want to compare the income between doctors and nurses, then it is an independent sample t-test if data follows normality. Clear, no? If you want to compare the height between males and females, then two group comparison height you are comparing, then again it is the independent sample t-test or is a non-parametric analog. Whenever you want to compare the average value of any of the continuous variable between two independent group, you can go for independent sample t-test. T-test is comparing two group average value. Can you tell one example now?
Duration of labor between primary and multi-mothers.
Okay. Pain, no, madam.
Duration of labor.
Okay, duration of labor. Yeah, very good. Duration of labor between two group. Madam mentioned that time I don't know how to repeat. So between two group mothers, yeah, very good. So if that duration follows normality, you can go for independent sample t-test. Usually time duration violates the assumption of normality. So if it is violating the assumption, you can go for the analog of independent sample t-test that is known as Mann-Whitney U-test. So I hope you understood when you should go for independent sample t-test. It is using whenever you want to compare the average value of any of the quantitative variable between two independent groups. Okay. Now see, we compared the SPP between males and females. Suppose if you want to compare the average value between SPP only, instead of male and female, you have one more group, third gender. Males are there, first group is there, females are there, then one more group, third gender. And if you want to compare any of the variables, so you should go for the test known as one-way ANOVA. Actually, ANOVA is an extension of independent sample t-test. What is the difference between ANOVA and t-test? T-test, we are comparing average value of any of the variable between two groups. If more than two group is there, we are supposed to do ANOVA. Clear, no?
Yes, sir.
In the previous situation, we compared the average SPP, whether it is same for males and females. But as a researcher, I want to know is there a significant difference in the average value of SPP between males, females, and the third gender. Instead of two group, I have three group, and I want to compare the SPP. So I supposed to do ANOVA instead of independent sample t-test. Is that clear?
Yes, sir.
Okay.
Yes, sir.
Yeah, so assumption is same for almost all parametric testing procedure. Assumptions are same. The first assumption, data should follow normality. First group, data should follow normal distribution. Second group, data should follow normal distribution. Third group also, data should follow normal distribution. Equality of variance, again using the same testing procedure. That means standard deviation of the first group should be equal to standard deviation of second group. That should be equal to standard deviation of third group. This is the two assumption we are supposed to check. For example, here I have a variable physical activity. I want to know the physical activity, mild level of physical activity, moderate level of physical activity, sedentary, and a severe level of physical activity. So different categories of participants are there in terms of their physical activity. Four categories are there. Few are doing severe level of physical activity, few are doing mild, sedentary, and moderate level. Okay, so four categories are there. Mild is there, sedentary is there, severe is there, moderate is there. Okay, so whether all the physical activity group have same SBP or not. So here we have four groups instead of two independent group. The average value of SPP is same for different groups of physical activity we are checking. So this is the way we supposed to write the hypothesis, and we supposed to as data follows normality, I perform ANOVA, one-way ANOVA, and we supposed to report like this. The same way is extension of t-test. So here, instead of a two group, now I have all the four groups: severe, moderate, mild, and sedentary. What is the mean in each group? And our what is this? F statistics. And here we have the p-value. Can you tell is there a difference in the average value? Just look at the p-value and tell. Is there any significant difference in the SPP between different groups of physical activity? Is there or not?
No.
No, not significant.
Whenever P is less than 0.05 only, we will reject the null hypothesis. Here, p-value is not less than 0.05, it is greater than 0.05. So we are not rejecting the null hypothesis. We are accepting the null hypothesis. Whatever hypothesis, this we are accepting. There is no significant difference in the average SPP between different levels of physical activity. So our conclusion is one-way ANOVA reveals that there is no statistical significant difference in the average SPP between different groups of physical activity. Clear, no? Now I will show you how to do the same way. First, you should check the normality split file based on the physical activity. Then that you can do already the data follows normality. I'm not going to repeat that step that you should do when you do for your research work. Now, here you have the option analyze. Compare means one-way ANOVA. Here you can select the variable SPP. What is the factor is actually the grouping variable. What is the grouping variable here? Alcohol, smoking, diet, physical activity reported as physical or diabetics. Which variable I should select here? Physical. Correct, no? This is the dependent variable and here it is the grouping variable. And the option, you can just go to option. If you want the mean standard deviation separately, you can just check this one. And if you want to check the homogeneity assumption, here option is there, but now I keep only the descriptive here. Continue. Click OK. So it will produce the output like this. See here. First group, second group, third group, fourth group, severe, sedentary, mild, moderate. What is the sample size? What is the mean and the standard deviation? So these points you should report. Then here the ANOVA, you should supposed to report the F value and P value. This is the P value, sig. So you can see here. Okay. So again, I will just crop this output. See here, when you report, no, you're supposed to report these points. Mean and standard deviation of a different physical activity level for the variable SBP. Then you should report this value, F value, and this is the P value. So when you write the P value, you should write P is equal to 0.930. So that means we are accepting the null hypothesis. There is no significant difference. Clear, no?
Yes, sir.
Is that clear?
Yes, sir.
Okay, just otherwise, even if we are not doing this test only, you can make out based on the values here. See, among the first group 149, second group also approximately 150, 149. There is no difference in the average value. That only test also tell you. Okay, I hope you understood what I want to convey. So the main point you should remember is ANOVA is actually the extension of independent sample features for more than two groups. Okay, so if you want to, if there is a significant difference in the average value, then you can go for pairwise comparison, known as if you want, is there a significant difference between severe and moderate, severe and mild, all these pairwise comparison. There is something known as a post-hoc test. That is a pairwise comparison. Different post-hoc is available. Takis post-hoc or Bonfroni that you can explore. That will tell you which pair shows the significant difference. Okay. Now I have one question for you. I have two group, independent group. I want to compare the average value. I am using independent sample titers only when data follows normality. So the main assumption of independent sample titers, whenever you have two groups and you want to compare any of the quantitative variable between these two groups, if your data follows normality only, you are supposed to use independent sample titers. If it violates the assumption of normality, what test you should use? The test name is known as Mann-Whitney U-test. You understood, no? Situation is same, but if data violates the assumption, you are supposed to go for Mann-Whitney U-test. So Mann-Whitney U-test is the analog of independent sample t-test, the non-parametric analog. Similar way, more than two group, if data follows normality, you should go for ANOVA. If data violates the assumption, you should go for Kruskal-Wallis ANOVA. Is that clear?
Yes, sir.
Okay. Okay, so if you have any doubt, you can ask me. So actually what I want to convey through my presentation, you should, whenever you have a data set, you should check the normality first for all the quantitative variable. If you want to summarize also, you should use that concept. Okay, for example, there is that. Okay, sorry. For example, if you have any variable, say SBP, cholesterol, height, weight, whatever variable you have in your research, you should check the normality first. Normality is very important. You can go for Kolmogorov-Smirnov test and you can check the normality, confirm the normality. Otherwise, you can just plot a histogram. Okay, so confirm the variable, the normality. If data follows normal distribution, report mean and SD, otherwise median and interquartile range Q1, Q3. Is that clear? So suppose your SBP follows normal distribution, you should report mean standard deviation. Suppose your height violates the normality assumption, what we should report? If height violates the normality assumption, what we should report? If it is not normal.
Median.
Very good. Not
Median
normal.
and interquartile.
We should report median and interquartile. This is very, if you want to tell something, okay, I know statistics. This is the very fundamental idea one should know whenever you do research. There is something known as normal distribution, and we are summarizing the data in terms of normality only. If data follows normality, we are supposed to report mean standard deviation, and otherwise median and interquartile range. Hypothesis testing also divided into two based on the normality. Whenever our data follows normal distribution, we will go for something known as parametric testing procedure. Otherwise, we will go for non-parametric testing procedure. Okay, for example, independent sample t-test is a parametric testing procedure. Mann-Whitney test is a non-parametric method. That means independent sample t-test we can use only when data follows normality. If situation is same and data violates the normality, you should go for Mann-Whitney test. I hope I conveyed what I supposed to convey. Anyone have any doubt? Is that clear? So once
again, regarding this, when to use Mann-Whitney and when to use Kruskal-Wallis?
1 second, madam. What you ask? When we should use Mann-Whitney and when we should use see, Mann-Whitney we are using, situation is same, but data not following normal distribution. When you check the normality for a variable SPP, it violates the assumption. Then you use, instead of independent sample t-test, Mann-Whitney test. These two are using for the same situation, but assumption when it is violating. Now we know how to check the normality. When you check the normality, if data violates the assumption, you are not supposed to use independent sample t-test. If data violates the assumption, you use Mann-Whitney test. Understood?
So then Kruskal-Wallis?
Kruskal-Wallis is saying if you have 3 groups, you are supposed to do ANOVA.
Okay.
ANOVA, whenever violates the assumption of normality, you should go for the non-parametric version of ANOVA, that is known as Kruskal-Wallis ANOVA. Clear, no?
Yes, sir, clear.
Okay. Yeah, fine. So again, I will just tell you the main point is you should check the normality, go to analyze non-parametric. Here you have Kolmogorov-Smirnov test, which variable you want the normality checking. For example, fat intake, click OK. This p-value will tell you. If you want graphically the histogram, go to graph. Here you have histogram option. Just select the variable age, display normal curve, click OK. It will produce for the variable age, it is normally distributed or not. See, what is the inference based on this graph? This is variable age, whether it is normally distributed or not. What do you feel based on the histogram graph?
Not normally distributed.
Yeah, the node looks like exactly a bell sheet. It's not somewhat a bell shape, but if you want to confirm, you can just go to directly, you can confirm at a test only you can use instead of doing all these things. So here, first I done a histogram and it is not exactly bell shaped. So to confirm the same, I'm going to do the Kolmogorov-Smirnov test. Test is telling it is violating the assumption. See, it is not normal. Okay. So if you want graphical way, you can just go to graph, legacy dialogues. Histogram will tell you whether the data follows normal distribution or not in terms of its shape. See, another variable fat intake. This also, it is not something, one tail is too much extended to this side, this tail is not there. Left side. Okay. So here that graphical representation is there. Now I want to tell you one more point, please. So up to here it is clear, not to everyone?
Yes, sir.
Yeah. So this is the main point. You should definitely check. If someone asks you, I have headache and all, you used to tell blindly, we will say, oh, you take $1 or paracetamol. That much knowledge even I also have. After that, I don't know. I will ask my friends, doctors and nurses, madam, how much dose I should take. I have fever, running nose, all those, blah blah. So similar way, if you are doing any research as a researcher, you should know there is something known as normal distribution. And based on that only, we are deciding which test we should use. There for each test, there is an alternative. Two form is there. One is the parametric method, one is the non-parametric method. Parametric we are using when data follows normality. So as a researcher, I should know how to check the normality. So we have Shapiro test and Kolmogorov-Smirnov test to check the normality. Otherwise, there's a histogram. If it is a well-shaped curve, you can say data follows normality. So this is a very basic one should know. Okay, I hope I conveyed something. Okay, so I just want to see everyone left. Oh yeah, some 5 participants left. Yeah, if you have any doubts, so lots of questions there. So we are running out of time. I will try to answer all these questions. So till date, till time what I explained is clear to everyone, no?
Yes, sir.
Okay, now I want to tell you only one more point. See here, I have here, we can report the mean and standard deviation. So there is a graphical representation bar diagram we used to write no for mean standard deviation. Whenever we report median and interquartile range, there is something known as box plot, the graphical representation of the word. Non-parametric data, median and interquartile range, usually we will report like this. See here, the median value middle line and lower quartile, upper quartile in the form of a box we will keep. Then we will draw one line to here, one line to here, and the extreme values we will, outliers we will report like this. So this line is known as whisker line. This line will give you what is the minimum value. This will give maximum value. There is a rule for that. Q1 minus 1.5 into IQ or interquartile range will give you the minimum of the data set. Q3 plus 1.5 into IQR will give maximum of the data. So if some value is beyond that limit, we used to say they are outliers. Okay, so actually the median and the interquartile range, IQR, we are reporting in terms of, we are representing in the form of a graph known as box plot. I will just show you where is that option there in SPSS. If you want to, for example, we know fat intake violates the normality assumption. Correct, no? So if you want to represent, when you report the median and interquartile range, you can just go to here, frequency already madam mentioned, you can just uncheck this one. Then where is that option? Yeah, this one you can click statistics, quartiles, click OK, OK. So it will give you what is the median. The median fat intake is 20, lower quartile is 15, upper quartile is 30. Correct, no? Now you want to graphically represent the same, go to graph. The graph is known as box plot. Select this option, define which variable you want. You can just select that. Variable is which one? Fat intake. Sorry, fat intake. Click OK. Again, I will show you, go to graph, box plot. This is a graphical representation of the not normal data. Select the variable fat intake, click drag here, click OK. See, software will produce something. This is the position of a number of the variable. And if you want to double click and if you want to remove that, you can just outlier, the position of outlier there displayed there. You can just remove that. You can keep like this. So lots of actually speaking, this all these diagrams in SPSS looks very very different. It's not that much friendly look. Okay, so you can use Excel for graphs. So this is optional thing only. If you want to report the median and interquartile in the form of a box plot, you can use this option. Go to analyze. sorry, go to graph. Here box plot option is there. Click here, simple graph, different variety, different group, different time point, everything you can plot here in the same window. You should select a fat intake, click OK, so it will produce the output. Okay, that is one optional thing. So these are the points what I want to convey. Actually, we are very sorry to the participants. We are running out of time. It is approximately 8:50 now. We know we exceeded the time. But if you have any doubt related to all these points what we discussed today, you can ask now. Not only related to what I covered last 1 hour. Dr. Amina also with us. If you have any doubts, you can ask now. We are ready to clarify your doubts. So before leaving my part, I just want to tell you once again, it is very, very important just to learn how to check the normality, that is deciding which test you supposed to use in your research and how to summarize. That point is clear to know, clear to everyone know? Hello?
So,
Okay. Yeah. So if you have any doubts related to the same, you can ask us. Now, as it is, I didn't mention lots of theory today because it is a software training program, no? So we are giving more importance. This all theory you're supposed to know as this is very basic fundamental things. Students may feel little difficult when you join as a professor in some other college after your degree. You will learn all these things because your students will come and ask you, madam, how to do these things. That time automatically you will learn all these things. Okay. So we hope you all enjoyed the program. Dr. Amita, we can wind up and we can move to the feedback session. Or if you have any doubts, you can ask us now. Yeah, participant, please, if you have any doubts, you can ask. Yeah, but here someone, Tanu Thapa asked if chi-square test we are doing when cell frequency is less than 5, you should go for, yeah, already madam explained, you should go for Fisher's exact test. Yeah. So if you have any doubt, you can ask me. Yeah, otherwise you can ask Dr. Amita. We are here. No doubts? Yeah. If you don't have any doubts related to the topic what we covered, if you want to share your feedback, you can share your feedback regarding the program, what you felt, whether it is in a positive comment or negative comment, whatever maybe. You can just unmute and you can mention your comment now. Otherwise, later we will share a feedback form with everyone. You can mention your comments there also. But if any of you want to share your comment now, please unmute and mention your feedback.
Okay, I think it's already late. So, as already mentioned in the chat, we'll be mailing you a feedback form. Please make sure that you're filling the form because if you fill it, only then you'll be able to get your e-certificate. So kindly go through that Google form and fill your name, your designation, your title, and everything